Determine all intervals of concave up or concave down and determine the coordinates of all inflection points, including cliffs, for the function f of x equals 6 plus 15x minus 12x squared minus 2x cubed. The first thing to do is find the domain. F of x equals 6 plus 15x minus 12x squared minus 2x cubed, which is a polynomial, and a polynomial has a domain that is all real numbers, or negative infinity to positive infinity. The next thing to do is find all candidate numbers. We need the second derivative for this. We will start with the first derivative. F prime of x equals, first term is a constant with no x derivative is 0. Second term is a constant with the x derivative is the constant. Third term is power rho, bring down the power, multiply with the negative 12, subtract 1 from it. Fourth term is power rho, bring down the power, multiply with the negative 2, and subtract 1 from it. We can now find the second derivative. F double prime of x equals, first term is a constant with no x derivative is 0. Second term is a constant with the x derivative is the constant. Third term is power rho, bring down the power, multiply with the negative 6, subtract 1 from it. We want to fully factor the second derivative. There is a common factor here of a negative 12. If we factor that out, that'll leave behind a positive 2 and a positive x. We can now set the numerator equal to 0 and the denominator, if there is one, also equal to 0, and solve for all x's. Because of the factor 2 plus x, we can see that x would equal negative 2. We now check to see whether this is in the domain. The domain is all real numbers. X equals negative 2 is a real number. It's in the domain. And so we keep it as a candidate number. It's a candidate to be a possible inflection point. We can now draw a domain line, a line representing the domain. It has no left end because it begins at negative infinity. It has no right end because it ends at positive infinity. We can put all candidate numbers on here. We have x equals negative 2, which breaks the domain interval up into two separate intervals. We can pick a test value in each of the intervals. The first interval is negative infinity to negative 2. Negative 10 is in that interval, and that can be chosen to be the test value. The next interval is negative 2 to positive infinity. 0 is in that interval and can be chosen to be the test value. We can now test the concavity in each of these intervals by plugging the test value back into the second derivative. We don't care about the value of the second derivative, just whether it is positive or negative. So the best place to plug in is the fully factored version of the second derivative. Plugging a negative 10 in there, 2 plus a negative 10 will be a negative, times a negative 12 will be a positive. So we have a positive second derivative, which corresponds to concave up. Plugging in the test value of 0 into the fully factored version of the second derivative, 2 plus 0 is positive, times a negative will be a negative. We have a negative second derivative, which corresponds to a concave down. So we have a concave up interval from negative infinity to negative 2. We have a concave down interval from negative 2 up to positive infinity. Right at the candidate number of negative 2, the concavity is changing from concave up to concave down. Since it changes, that makes negative 2 be an inflection point. So we have an inflection point. It has an x-coordinate of negative 2 and has a corresponding y-coordinate that can be found by plugging negative 2 back into the original function. So y will equal f of negative 2, which is 6 plus 15 times negative 2 minus 12 times negative 2 squared minus 2 times negative 2 cubed. which will be 6. 15 times a negative 2 will be a negative 30. And then we have a minus 12 times a negative 2 squared, which is a 4. And then a minus 2 times a negative 2 cubed. A negative to an odd power is negative, and then 2 cubed is an 8, so that'll be a negative 8 overall. So we have 6 minus 30, which is a negative 24. We have a minus 12 times a 4, which is a negative 48. And then we have a negative 2 times a negative 8, which is a positive 16. Negative 24 minus 48 is a negative 72, plus 16 is a negative 56. And that'll be the corresponding y-coordinate. So we have one interval of concave up, one interval of concave down, and we have an inflection point occurring at negative 2, negative 56.